Good afternoon, class. Here's Pre-Calculus, Chapter 1, Function, Section 1.1, Functions and Function Notation. In this chapter, we will cover function and function notation, domain and range, rates of change and behavior of graph, composition function, transformation of functions, absolute value functions, inverse functions. The objectives of this section is to determine whether a relation represents a function, find the difference quotient of a function, determine whether a function is one-to-one, use the vertical line test to identify functions, graph the functions listed in the library of functions. One point one, functions and function notation, dependent and independent variables. For an equation in variables x and y, if the value of y depends on the value of x, then y is the dependent variable and x is the independent variable. Relation. It is a set of ordered pairs, x, comma, y. Domain, the set of all input values, x values independent variable for a relation. Range, the set of all output values, y values, which is known as a dependent variable for a relation. So if we look at this, domain, whatever is covered along the x-axis, range, whatever is covered along the y-axis. Function, a function is a relation in which each element in the domain corresponds to exactly one element in the range. Meaning the x coordinates cannot repeat. The graph of a function or relation is the graph of its set of ordered pairs. Here's the person. Here's an example of a function. 1, Tom is 21, Bob is 22, Mark is 25, Bill is 20. And this is not a function. Tom is 21, Tom is also 22. Tom can't be both 21 and 22 at the same time. That's the idea behind the function. The x coordinates, the independent variables, cannot repeat. The example 1, determine whether each relation represents a function. If it is a function, state the domain and range. When we look at part A, we notice 2 repeats. No, it's not a function. The element 2 is assigned to both 3 and -1.
C is not a function.
No, it's not a function. When we look at part B, we look at the x coordinates. They're all different. Yes, it is a function because no ordered pairs have the same first element and different second elements. So the first coordinates, x coordinates, do not repeat. The domain is -2, +4, +3, +2, and range is +3, +1, -2, -1. So we can write the domain and range. Part C, you look at the first coordinate is 4, over here is 3, and over here is repeat. It's repeating. You don't even have to go further. When you look at this one and this one, it fails to be a function. So No, it is not a function. The element 4 is assigned to both 3 and -3. It is not a function. Example 2, determine if the equation defines y as a function of x. So you want to see if the first coordinate, the independent variable x, repeats or not. And this is a function. Yes, this is a function since for any input x, when you multiply by -1/2 and then subtract 3, you would only get one output y. In other words, you have to solve for y to see if it's unique or not. It is already solved for y. However, if you look at this example, we want to solve for y to see what happens. To solve for y, we're going to move the 1 to the other side. So y squared is x minus 1. To solve for y, we take a root of both sides. So y becomes plus minus square root of x minus 1. So this is not a function. No, this is not a function. Since for values of x greater than 1, has to be greater than 1, by the way, you would have two outputs for y. The reason it has to be greater than y because you're dealing with a square root. You remember the domain for a square root. And the index is even. What's underneath must be non-negative, greater than or equal to 0. What about this one? The same thing. You solve for y. The way you solve for y, first you move the x squared to the right. And then you take a root. Y becomes plus minus. This is the one that makes it to be not a function. So the answer is no. For values of x between -1 and 1, it can be shown that x is between -1 and 1. Two values of y result. And of course, as an example, if x is 0, an easy example, y is plus minus 1, and that's all you need. Even if you show one example that it fails, then it's not a function. Find the value of a function f of x equals to x squared minus 3x for what you see here. So for example, f of 3, simply put, we want to plug in. This is evaluating the function at a specific number. So what is f of 3? We plug in 2 times 3 squared minus 3 times 3. 3 squared is 9. 2 times 9 is 18. Minus 9 makes it 9. A part B, f of x plus 3. Well, f of x is this. F of 3 is 9. Add them up. So we're going to add this one and 9. We get 2x squared minus 3x plus 9. Part C, 3 times f of x. So 3 times that. Distribution will result in 6x squared minus 9x. F of negative x means replace the x with negative x here. So 2 times negative x quantity squared minus 3 times negative x. I hope you know that this is x squared, class. Minus x quantity squared is also x squared, but minus x squared is minus x squared. So number 1 and number 2 are two different things. What is the difference? This one negative is being raised to the power of 2 becomes positive. This one negative remains outside. First raise this to the power of 2 and then multiply by negative. So those are two different things. So 2x squared plus 3x is the answer. Minus f of x. Minus f of x, that means multiply each piece by negative. So minus f of x means minus of this expression, which is to distribute the negative over the expression 2x squared minus 3x. We get minus 2x squared plus 3x. F of 3x means replace the x with 3x here. So 2 times 3x quantity squared minus 3 times 3x. Of course, this is 9x squared. 2 times that makes it 18x squared minus 9x. Finally, part G says f of x plus 3. That means replace the x with x plus 3. So you have 2 times x plus 3 quantity squared minus 3 times x plus 3. And I'm going to remind you that a plus b squared is a squared plus 2ab plus b squared. And if we had a minus b quantity squared, this would be minus. So 2 times this one squared, you get x squared. 2 times this one makes it 6x, and then square this, you get 9. So 2 times x squared plus 6x plus 9, following this, minus 3x minus 9. Now we distribute the 2. We get 2x squared plus 12x plus 18. 12x and negative 3x, they add up to 9x. 18 and negative 9, they add up to 9. And the final answer is 2x squared plus 9x plus 9. Example 4, find the difference quotient of a function for the function f defined by f of x equals minus 3x squared plus 2x. Evaluate the dq short for the difference quotient. Difference quotient in essence is the same as finding the slope of a line, a secant line, which is rise over run. But this format, f of x plus h minus f of x over h, where h can't be 0, is used in calculus. That's why they use the dq. So basically what it says, into this fraction, you replace f of x with f of x plus h. This one is very simple. You just put the same thing here, put h here. Basically, you have to evaluate this one. That's all there is to it. So that means minus 3 times x plus h quantity squared plus 2 times x plus h, and then minus f of x, just write it down. negative 3x squared plus 2x. Again, we use what we had there, x plus h quantity squared. Remember, it's x squared plus 2xh plus h squared. So this one, all you have to do is simplify the numerator. So this one is x squared plus 2x plus h squared. You keep the negative 3 intact. This one is 2x plus 2h. This one is plus 3x squared minus 2x. You are distributing. Let's distribute. Negative 3x squared, negative 6xh, negative 3h squared. Negative 3x squared, positive 3x squared, they cancel each other. Positive 2x, negative 2x cancel each other. What are we left with in the numerator? Minus 6xh, minus 3h squared plus 2h. So these three terms, everybody, is left in the numerator. 1, 2, 3. All of which have a common h. So we take the h out from this one, and this one. We get h times minus 6x minus 3h plus 2. So again, this one, and this one. Take a look. If you distribute, you get this one, and this one. These two cancel each other. The final answer is minus 6x minus 3h plus 2. You have to be very comfortable with this when you go to calculus, because there we take the limit of that expression, and ultimately the h in the denominator must go away if it's done properly. Let's repeat the question for f of x equals 2x squared minus 3x. For the function f defined by f of x equals 2x squared minus 3x, evaluate the dq. We had done this with various functions. We want to do it with this one now. So to evaluate this, as I mentioned, this is easy. This one just repeated here. This is the one we want to evaluate. F of x plus h means 2 times x plus h quantity squared minus 3 times x plus h. Two times x plus h quantity squared. First of all, x and h. This is x squared. This is 2xh plus h squared. Hopefully we have no problem with those identities. And the 2 in front remains. Minus 3x minus 3h. Minus 2x squared plus 3x. So we have 2x squared plus 4xh plus 2h squared. And now we are going to simplify the numerator as follows. 2x squared and negative 2x squared cancel each other. Negative 3x, positive 3x cancel each other. We are left with 4xh, 2h squared minus 3h and nothing else in the numerator, all of which have h in common. So we take the h out. If I factor the h out, this gives me 4x. This gives me 2h. This gives me negative 3. I can drop the common factor of h. And the parentheses 4x plus 2h minus 3 is the final answer. So those are pretty straightforward. Let's look at finding the difference quotient of a function for something more interesting. For example, f of x is a fraction, 4 over x is a rational function. So let's see what the technique is. You want to evaluate this. F of x plus h becomes 4 over x plus h. This one just repeated over h. Now, because this is a complex fraction, the technique involved to simplify it is to multiply the top and the bottom by LCD. The top has 1 and 2 fractions. The bottom doesn't have any. So those 2 fractions have a LCD x times x plus h. So we are going to multiply this and this, both of them by x times x plus h. This is the technique you need to know for the next course. LCD. So what happens when we want to multiply? I want to quickly show you to remind you something you've seen. Of course, the denominator is the product of these two. Just don't touch it. H times x plus h. The numerator, when you multiply this one by this one, x plus h goes away, you get 4x. When you multiply it by the next one, you get minus a 4 times x plus h. So let me quickly show you that. I want to show you the numerator only. So this would be 4 times x, the numerator, minus 4 times x plus h. And as I said, the denominator is the product of this. Therefore, the numerator is 4x minus 4x minus 4h. As I said, the denominator, you just write it as a product. Let's simplify. These two cancel each other. 4x and minus 4x. The numerator is minus 4h. You drop the h, you get minus 4 over x times x plus h. This is a very important technique that you need to know. LCD. F of x equals square root of x. BQ, the difference quotient would be, following this, f of x plus h, that means square root of x plus h, minus f of x, which is square root of x over h. The way we deal with this, because ultimately you want to simplify it such that it be ready to tackle limits, you multiply by the conjugate of the numerator. Let me remind you of that. Conjugate of a plus b is a minus b, and their product is a squared minus b squared. So the conjugate of the numerator is negative changes to positive. You not only multiply by it, also divide by it. The reason you do that, because this expression is equal to 1, everybody. So what do? First, I want to tackle the denominator. You do absolutely nothing. You write them as a product, H, and then you put this in a parenthesis. You don't do anything. The reason is because ultimately, when you work on limits, you let H go to 0, and you're really hoping that you get rid of the H because the denominator can't have a 0. And this is the technique to get rid of it. So the denominator remains as a product. What happens to the numerator? You have A minus B times A plus B. In fact, let me write at top of it. Let's assume this is A, this is B, so A minus B, A plus B. So their product is A squared minus B squared. When you square this, you get, I'm looking at the numerator, square root of x plus h squared minus square root of x quantity squared over, I'm going to write den, denominator. So what happens? This comes out and this one comes out. So you get x plus h. So this comes out. You don't have to write this step. I hope you understand. It's a squared minus b squared. This comes out as x plus h minus x. These two cancel each other. The numerator has nothing but h. H cancels out the h in the numerator, in the denominator, and the numerator is left with only number 1. By the way, just because it's coming up, ultimately, you change the h to 0, and the denominator becomes 2 square root of x. This one you change to 0, and you get 2x in the denominator. That's what is coming up. Library of functions. There are elementary functions we should be familiar with as far as their graphs is concerned. When we know the graph, we know everything there is to know about them. So for example, f of x equals square root of x is one of it. And one easy way, let's graph that by putting just a few easy numbers. For example, if I put 0 in it, square root of 0 is 0. If I put 1, square root of 1 is 1. If I put 4, I get 2. If I put 9, I get 3. If I put 16, I get 4. I don't know. If I put 100, I get 10. So I'm going with easy numbers. So I don't need a calculator. Of course, I can put, for example, 2, and I need square root of 2, which is about 1.41. So if I plot those pairs, it looks something like this. Or like that. Maybe one is more to scale, but that's the concept. Now, these are interesting information and facts about a function we need to know. So what are the intercepts, for example? Let's discuss all of this. The x-intercept and the y-intercept are the same, 0, 0. When the graph crosses the origin, x and y-intercept are the same, 0, 0. Domain is the portion that is covering the x-axis. As you can see, it covers from 0 to infinity. And range, the portion that covers the y-axis. Also, this ultimately goes to infinity. It covers 0 to infinity. So domain is 0 to infinity. 0 is included. Range is the same thing, 0 to infinity, but we mean this one. So to distinguish between the two, you need to know this means x greater than or equal to 0. This means y is greater than or equal to 0. That's the meaning of it, okay? All right. The concept of symmetry, even and odd. The function is neither even nor odd, and it has no symmetry. What am I talking about? The even symmetry, as you recall, f of minus x equals f of x, which makes it symmetric with respect to the line, to the y-axis. The odd symmetry means f of minus x equals minus f of x, which makes it symmetric with respect to the origin. And if you look at f of minus x, you replace the x with minus x, and it's none of the above. Therefore, it's neither even nor odd. Increasing, decreasing. In short, increasing means when x gets larger, y gets larger. Decreasing means when x gets larger, y gets smaller. And as we go to the right, x gets larger, y gets larger. So this is increasing everywhere from 0 to infinity. And when you write increasing, decreasing, you just use open interval. That's why you don't include the 0. Max and mean, obviously, it does have a minimum. It stops here. When we say minimum, we are referring to the y coordinate. So absolute mean equal to 0, the y coordinate at 0, 0. We don't have a max because it continues indefinitely, it goes to infinity. Max is when you can pinpoint a pair as x comma y, the y coordinate is the max. So absolute mean is that there is no max. So there is no max. Another elementary function we should be familiar with is the cube root of x. And we do the same thing. We pick easy numbers. For example, 0 cube root of x is 0, 1 is 1, negative 1 is negative 1, 8 is 2, 27 is 3, minus 8 is minus 2, minus 27 is minus 3. So again, because we want to avoid using a calculator, so those are the pairs. And if we plot that carefully, it looks something like this. So we want to discuss the same topics. What about the intercepts? There is an intercept of 0, 0, which is both x and y intercept. Domain, whatever we cover along the x-axis, it covers everything from negative to positive infinity. Range, anything that is covered along the y-axis, this covers everything from negative to positive infinity along the y-axis. We want to look at, to answer this question, you look at f of minus x. So what is f of minus x? Replace the x with negative. As you recall, because it's an odd index, if the number is positive, the answer is positive. If it's negative, the answer is negative. So you can take that one out because, in fact, this cube root of negative 1 is negative 1. That's why. So f of minus x is minus cube root of square root of x, which makes it minus f of x, which makes it an odd function, which makes it symmetric with respect to the origin. So the function is odd. You proved it. And symmetric WRT with respect to the origin. Is the function increasing or decreasing? As you can see, when we go from left to right, the y gets larger and larger, and therefore it's increasing everywhere from negative to positive infinity. What about max or mean? We don't have any of them. None of it. F of x equals absolute value of x is also an elementary function we should be familiar with. And as you recall, by definition, absolute value of x means distance from zero. So absolute value of x is x if x is larger than or equal to zero. Otherwise, it's opposite. Minus x doesn't mean a negative number. It's the opposite of x. And that's when x is zero. I want x is less than zero. I want to make sure we understand this concept. If I'm looking at absolute value of 4, the answer is 4. So we are looking at this part. It says when inside the absolute value, you have a number which is positive, you just drop the absolute value. But if I have -4, then I'm here. So I need to write the opposite of this to make it positive. So it is important to understand the meaning of absolute value. This is not saying negative value. It says the opposite of x, which becomes positive. So when what's in there is positive, you can drop the absolute value. But what's in there is negative, you write its opposite to make it positive. So we can do the same thing. We can pick up a bunch of numbers. Those are easy numbers. Let me erase. So we pick those numbers and the y coordinates are the same thing but positive. So 0, 1, 2, 3 is easy. This becomes positive. This becomes positive. And now the pairs are -2, 2, -1, 1, and so forth. We plot those pairs and it looks like what we call a V shape. Looks like a V shape, everybody. Now, we want to discuss the issue. So starting with the intercepts. Of course, 0, 0 again is the intercept, which makes it both x and y intercept. Domain. This side covers the left side. This side covers the right side of x. So the domain is all real numbers, negative to positive infinity. Range. One easy way, class, again, as far as the domain, try to lay it down along the x-axis to see what happens. This one, lay it down along the y-axis. It only covers from 0 up. So it's from 0 to infinity, 0 is included, but it doesn't cover the bottom. That's how you figure out the domain or range. Lay it down along the x-axis for domain, along the y-axis for the range. So we want to discuss this. We want to look at f of minus x. F of minus x is absolute value of minus x, which is the same as absolute value of x, because inside you can separate the negative sign and it comes out as positive, because the absolute value of negative number and positive number are the same. F of minus x is identical to f of x. According to that, becomes an even function. Even the graph is showing that it's even because it's, look at it, it's symmetric with respect to the y-axis. The function is even and it's symmetric with respect to the y-axis. Where is this function decreasing? I hope you recognize this is as decreasing. So from negative infinity to 0 is decreasing. And I hope you recognize this portion as increasing. So from 0 to infinity. Decreasing is just like a negative slope, increasing like a positive slope, because even if you have a graph that is a curve, the same concept. Maximum, minimum, obviously, absolute minimum is equal to the y coordinate of this point 0 at 0, 0, and we don't have maximum, so none. So this one, none. We don't have a max. So let's look at this library of functions that was explained. One of them is a constant f of x, or y equals a number such as b. Then it becomes a horizontal line with the y-intercept of 0, b, where b is part of the range, if you will. The range, there is, okay, domain is all real numbers, range is only p. Again, of course, this R is a set of real numbers. Identity function, f of x or y equals x, goes through the origin. By the way, the domain, as I mentioned, is all real numbers. And the range is only one point along the y-axis, which is b. So this line, y equals x or f of x equals x, and that has a domain and range, both of which are all real numbers. Negative to positive infinity, negative to positive infinity. Square function, y or f of x equals x squared. You should know it looks like that. Everybody knows that. The graph is called the parabola. Domain, all real numbers, range from 0 to infinity. Cube function, f of x equals x cubed, it looks like that. A domain, all real numbers, range, all real numbers. F of x equals square root of x. The root functions, we have graphed them. So we remember the graph looks like this for f of x equals square root of x, and looks like this for cube root of x. And domain for this one is from 0 to infinity. Range for this one is also 0 to infinity. And for this one, domain and range are both all real numbers. So from negative to positive infinity. We also have what's called reciprocal function, f of x or y equals 1 over x. And if we were to graph it, it's the rational function has horizontal asymptote and vertical asymptote. So the domain is all real numbers except 0, and the range also is all real numbers except 0. How do we show that? We say the domain is from negative infinity to 0, union 0 to infinity. You have parentheses to exclude 0. Range is the same thing. That means along the y-axis, of course. Negative infinity to 0, union 0 to infinity. You set it up in this manner in order to exclude 0. Another function is called greatest integer function. And we use double brackets to represent that. F of x is double bracket x, that is the greatest integer function. By definition, greatest integer less than or equal to x. That is the greatest integer function. What do we mean by that? So I want you to see that. So the greatest integer function is defined as the function that provides the greatest integer less than or equal to a given number, denoted as double brackets and x is inside. Where x is the input number, it returns the largest integer that is not greater than x. For example, let's look at these numbers and let's see what happens. When you're dealing with an integer, the answer is itself. So -1 gives you -1, 0 gives you 0, 1 gives you 1, 5 gives you 5, 10 gives you 10. Any integer, the answer is itself. Big deal. But when it's not an integer, think about this. This is -0.5. Okay. This is -0.25. And both of them, the answer will be -1. So this is -1 and we know it. So and I'm gonna, this we know it's -1. This is 0, so it's not a problem. This one, -0.5. Let me write it in a decimal so you understand what I'm saying. This is -0.25. Remember what this says. It's the function that it returns the largest integer that is not greater than x. Okay, so it can't be greater than this. So if you use 0, it becomes greater. So you have to use -1 for each one. 1/4. Again, it's probably easier if you see it as a decimal, 0.25. If I choose 1, is larger than that. But if I choose 0, this works. So this should be -1, -1. This should be 0. This should be 0. This should be 0. But if I have, let's say, 1.2, then it returns 1. Okay? It returns integer. If I have 7.1, it returns the 7. That's the idea. So let me erase my work. Those are the numbers. As I said, if you have an integer, it's itself. So it's easy. But if you don't have an integer, if you have a number in between, pick the integer smaller than the number. So the integer smaller than -1/2 is -1, the closest one, of course. The integer smaller than this number, and the closest one is -1. 1/4, you can't choose 1. You have to choose the integer smaller than that, 0, 0, 0. So those are the pairs. If you graph them, it looks something like that. Meaning, so this is the x-axis, this is the y-axis. And by the way, this has infinitely many discontinuities. This is also known as step function because it looks like a step. I write that. So what this means is if you pick a number that is 0 or anywhere between 0 and 1, 0.1, 0.2, 0.9, 0.8, whatever you want to pick, the answer is 0. That's why it's this point. But between 1 and 2, it's 1 or 1.1 or 1.5 or 1.9 or 1.8 or 1.4, doesn't matter. The answer is just 1. If I want to look at this one so you can see that from 4 to 5, the answer is 4. The moment you hit 5, it goes up. So if I hit 5, I get to that point. That is the idea behind the greatest integer function. All right. Normally, when they want to charge with postal cost or phone, if it's portion of a minute, they round up and so forth. That is the way things are used. They go up instead of going down. Of course, when they want to charge you, they want more money. Vertical line test. If a vertical line can be drawn so that it intersects a graph at more than one point, then the graph does not represent a function. If a vertical line cannot be drawn so that it intersects a graph at more than one point, then the graph represents a function. That's simple to see. As you can see, this is a function because no vertical line can cross it more than once. This one is a function. This one, not a function. It's a function, function, not a function. Clearly not a function. You don't even have to draw a vertical line. This is a vertical line. However, this has the equation x equals y squared minus 2. Parabola that opens sideways shown is not the graph of a function of x. You can cut that into two pieces and each one becomes a function. The parabola, however, does contain the graph of two functions of x if you cut them in half as follows. The top half, y equals square root of x plus 2, and the bottom half is y equals minus square root of x plus 2. For each graph, determine the domain and range, then state whether each relation is a function. Bear in mind this has coordinates 1, 0. So the domain is along the x-axis from 1 to infinity, and the range has no limit along the y-axis or real numbers. So domain is 1 to infinity, or x such that x is greater than or equal to 1. Again, lay it down along the x-axis. What does it cover? This portion. Range is all real numbers because this continues indefinitely. It covers the entire y-axis. Is this a function? No. It fails the vertical line test. Therefore, see, you see 2 points. Therefore, it is not a function. In this case, you want to lay it down along the x-axis. This portion covers the positive side. This portion covers the negative side. Domain is all real numbers. You can write all real numbers or negative to positive. What about the range? It's just this. This point has coordinates 0, -1. So if you lay it down along the y-axis, covers from -1 to infinity. So you can say the range is -1 to infinity, of course, with bracket -1 is included, or y is greater than or equal to -1, because we want to make sure we understand the difference. Is this a function? We can't come up with any vertical line that fails. Therefore, yes, it is a function. So there is no vertical line that crosses the graph more than once. The answer is yes. Which of the following are graphs of functions? Y equals x squared. That represents a function because no vertical line can cross it more than once. Y equals x cubed. Yes, it is a function. No graph, no vertical line can cross it more than once. This one clearly not a function. This one clearly not a function. So yes, this is a function. Y equals x squared is a function. Y equals x cubed is a function. X equals y squared. This vertical line crosses the graph more than once. It fails to be a function, not a function. And of course, this is a parabola that opens sideways, and this is an elliptical shape. vertical line crosses the graph more than once, x squared plus y squared equals 1. Of course, this is a circle, everybody. It doesn't look like it, but this is the equation of a unit circle, in fact. So this is not a function either. So pretty straightforward. Use the graph to find the value of the function f of 4, f of 6, f of 8. So f of 4, as you look at this point, has coordinates 0, comma. It has coordinates 4, comma 0. 4, comma 0. So when x is 4, y is 0. That means f of 4 is 0. F of 6, here's the location. It seems to be x coordinate is 6, y coordinate is about 1.5. Therefore, f of 6 is 1.5. We are trying to read the graph. F of 8. It seems to me when x is 8, y is 2. So f of 8, therefore, must be 2. Use the graph to find the domain. Domain is what is covered along the x-axis. So what does this cover along the x-axis? This portion, which goes from 0 to this number, 7. 0 is included, 7 is included. What is the range? What does this cover along the y-axis? The very bottom covers this one, the very top covers this one. So it covers somewhere from here to here, which is from -2 to +4. 1-to-1 functions. A function is 1-to-1 if each element in the range corresponds to exactly one element in the domain. In other words, the x doesn't repeat, it makes it a function. Now the y can't repeat either. We had the vertical line test for a function. Now we add the horizontal line test, HLT, for a 1-to-1 function. If a horizontal line can be drawn so that it intersects the graph of a function at more than one point, the graph is not a 1-to-1 function. Here's a function. It crosses, there is no vertical line that crosses the graph more than once. However, it is not a 1-to-1 function because a horizontal line that crossed the graph more than once. However, you can cut it into two pieces, the right piece and the left piece. Each one becomes a 1-to-1 function. Another way of approaching it, a function f is 1-to-1 if for any two numbers a and b in its domain. When f of a equals f of b, that results that a must be equal to b. And when a is not equal to b, then f of a is not equal to f of b. This is another way of approaching it. Are the following sets functions 1-to-1 functions? Let's find out. When we look at part A, function A, I'm just interested in the first coordinate, 1, 3, 4, -2. They are all different. So A is a function. Let's look at B. 1, 3, 4, -2. They are all different. So both sets A and B represent functions, since each x coordinate corresponds to exactly one y coordinate. Now let's check the second part. Let's look at part A. So they are both functions. Let's look at their y coordinate. 2 and 5 and 6 and 1, they are all different. That makes set A a one-to-one function. So set A is also a one-to-one function, since each y coordinate also corresponds to exactly one x coordinate. Let's look at part B, or function B. This is 2, okay? Different than 5, so far so good. Different than 6, so far so good. Just the same as this one. In other words, take a look. This second coordinate is 5. Second coordinate is 5. Therefore, it's not a one-to-one function. Set B is not a one-to-one function, since the y coordinate 5 corresponds to two x coordinates, 3 and -3.